Good morning, everybody. We are going to do 6-4 today. That is the second fundamental theorem of calculus. Remembering FTC is the integral from a to b of f of x dx, where that equals f of b minus f of a. We know that capital F stands for the antiderivative. Wonderful work. We are starting to figure these out without a calculator and learn certain rules. We do come to the world where we had chain rule involved, okay? At that point, so when we're looking at these, all of these involve chain rules, so we cannot find the antiderivative. So we're going to come here and we say sine f of x equals sine of x squared. You can see how we would have had to use chain rule. So instead, we're going to use the fundamental theorem there. And instead, using f and b, we're going to use a is 0 and b is x. So that'll look like this. Okay, so we've just plugged in the different things. We start with 0, because if I'm going to go 0 to 0, I'm not going to have any area underneath. That's always going to be nice. The x is the variable we're going to be looking for. You want to notice I changed this to t here. We have to have a different variable to be plugging in to. So, options, let's flip this over. If we have that it is f of 0 is 0, then it just plugs right in and we don't have to deal with it. If f of 0 equals something else, we would just add that on to the integral. So for the second fundamental theorem, if f is continuous on the interval and a is any number in the interval, then we can write that f of x equals f of a plus the integral from a to x of f of t dt. So now we're going to use that skill here, okay? They're giving you, here's your function, they're giving you f of 0 is 3, and they'd like to find f of 4. So I will write an integral from 0 to 4 of my function. I know that that equals f of 4 minus f of 0, so I can move things around, so that looks like f of 4 equals f of 0 plus the integral from 0 to 4 of sine of t squared dt, okay? Now, so f of 0 is 3, that plugs in right there. This section, so at this point we're still learning skills, so at this point we'll put that in the calculator. Plug that into the integral button, and you will get 747. So f of 4 equals 3.747. Okay? So you're going to go through here. Number 2, I'd like you to try that one. I will tell you the answer should come out, f of 2 should equal 5.882. All right. One more right here. Let's look at this. So we're going to say we want it in terms of x. So g of x equals, that would be g of 3 plus the integral from 3 to x. Okay, you want to leave it like that. And then we would say of cos of t squared dt. Filling in, g is -2. And again, using the fundamental theorem, the top variable, my b, is what's out here. So you want to make sure you have that all set. And then that is your correct notation in terms of x. Okay, looking at the last one, you just have to do a quick thinker there. If it's saying x to 1, to use the second fundamental theorem, we want to switch that, so you're going to negate the integral, okay? Now, we have some exciting stuff right here. These are fun. You're going to enjoy them, whether you like it or not. These show up in the multiple choice. They're there every year. They look scary, they look complex, they're not. Okay, if you look at the steps of what's going on here, it's saying taking the derivative of the integral. So you could go through, do all that work, take the integral, plug in the bounds, then take the derivative of that answer. You're going to get what you have right inside here. So when you see that you have the derivative of the integral, your answer will be sine of 2, plugging in the x. Okay? And there's your answer. Now, of course, it gets a little more complicated because we like to do it that way. I'm going to show you this, and then you can do both U tries. Here we go. Now, you can see the difference between 1 and 3 is that when I plug in the x squared there, so sine of x squared, when I dealt with that, I would have to be dealing with chain rule. So if whatever's up here in position B, you're going to just make sure you multiply by that derivative. Okay? I'll tell you these answers when we get to class because there's no real point if I write them down for you. You have to figure them out. So go through, plug in the top value, and then if there's anything extra, make sure you take the derivative of that. Enjoy! See you guys soon!